What's poppin'? Hello, everybody. It's Jared with Robotic Engineer Automation coming at you with another awesome video on Fanuc Robotics. Today, we are going to be covering DCS, some stuff in DCS, speed checks, Cartesian zones, safe IO, and digital IO. So, if you're just whizzing by and you're looking for something specific, be sure to check out my chapters. They are located below in the description with timestamps. Really quick, if you guys are emailing me for manuals, just make sure when you email me, which my email is located on my channel in the About section, I think. If you're emailing me for manuals, just make sure you respond with your Gmail because I can't, these files are too large to email. I have to give you access to my share folder, and I can't give you access if you don't have a Gmail. So make sure you send me that Gmail and make sure you're downloading them when I give you that link because access will expire after so long. So just make sure you're getting those downloaded. Also, I have IO sheets available for Fanuc Robotics as well. They're blank, the template. They're set up similar to how I set up this IO that we're going to go over. So we're going to look at the IO sheet. And if you guys want to email it to me, I'll send it to you. Don't need share folder for that. And I won't even charge you. So as always, if you enjoy the content, you want to see more, or you just like my face, be sure to hit the subscribe button, smash that like button so I know that you guys are digging the content that I'm putting out there. And if so, I'll make more of it. So let's get into it. All right, guys, thanks for joining me. Let's get right into it. So we are going to jump into, well, first, I want you to take a look at the software options that we are going to be using very quickly. So for this, we are going to be using Advanced DCS Package, but you are also going to need Ethernet IP Safety. You got to have those two options. If you don't have them, then you can't do what we're doing, or what I'm going to show you that we're doing. But I do think there is a cheaper version out there for Advanced DCS Package, but just throwing that out there. So here we have a simple, super simple work cell. We have a picking and a placing. I have two Cartesian zones set up. But before we get into our zones, let's take a look at our IO. So as you guys have seen in previous videos, I set this robot up all on one slot. As far as digital IO goes, it's all one slot. So let's take a look at our safety. I sure hope this recording thing doesn't get in the way of my video some point down the road. So this is a screenshot. This safe IO is a screenshot of my DCS safe IO that I have. This is a screenshot, so I'm going to pull this out of the way and we're going to go over a couple things. So we have the typical fence circuit, e-stop circuit coming in as SIP safe input 1 and 2. You don't add, it doesn't have to be 2 and 3. Sorry, not 1 and 2, but it does not have to be 2 and 3. That's just how I set it up because system safety output 2, system safety output 3 is the fence is 2, and the external emergency stops is 3. So it just lines them up, but it doesn't have to be like that. So that's just to from the PLC to the robot, fence and e-stop. So it's very minimal. If you want to see what this might look familiar to some of my subscribers that have seen my videos in the past, this is all encompassing. So if you have a servo disconnect, which we don't have, another servo disconnect signal, like some of these are just redundant, and we just don't use a lot of these. Signals. These CSOs here on the left-hand side, these are all SIP safety outputs. So they're all just statuses over the safety network. That's all those are. But so I'm going to go back to this one. This is the one that we're currently using. So there's a couple cool things you can do with SIP safety outputs. You can set them to Cartesian zones. You can set them to Cartesian zones. So the way this works is, like say if you have a Cartesian zone set up, and I know I'm getting a little ahead of myself, but I just want to show you on the safe IO side, they're labeled in according to the order that you made them. So CPC 1 would be your first one, CPC 2 would be your second one, so on and so forth. So when I said CSO 1 and 2, SIP safety outputs to the PLC, inputs to the PLC, CSO outputs from the robot, CSO 1 and 2 equals Cartesian Position Check 1 and 2. The way the output works is when the zone is clear. When you are not in the zone, the output is held high. When you are in the zone, the output is low, as I commented here. We can see a great example of this right now. So if I go to my SafeIO Connect, I go to my SIP safety outputs, we can see that they're both held high. I'm clear both of the zones. When I go into this zone, you're going to see CSO1 turn off. It's pretty cool. I think it's pretty cool. It's very handy for when you're trying to send statuses to the PLC, whether you're in or out of a zone, because it's really important to let the PLC know, hey, we're in this zone. Do not turn this conveyor on. That way, you never have to worry about turning a digital output on and off throughout your logic. The Cartesian zone takes care of all that. It takes care of all of that stuff. You do not have to turn an output on or off. The Cartesian zone sets all of that stuff up. If for some reason you set up this Cartesian zone, these are not restricted zones. As you can see, the robot just went into that zone. Easy peasy, right? If you want to set it up that way, they have to be set up as a non-stop. And this is how you do it. So we go to Menu, Next, System. We go to DCS, and we press Enter on the teach pendant. We go to our Cartesian Position Check. I'm going to toggle up. And again, I understand that I might be all over the place because there's a lot. We got a lot to cover. I'm going to try to be very quick about this. Even in my Cartesian zone, I have it commented in here in the comment as a nonstop to let the person know who's reading this, hey, this has nothing to do with safety. There is nothing safety, anything happening with this zone. It is purely for the sake of sending signals back and forth. I defined that, and here in the stop type, when I pressed choice, and I called it a not stop. That took away the safety. That way I can go in and out of the zone, and it's purely used for signals. And I'll go in more detail here in a few about this Cartesian zones and how to set them up as restricted zones, working zones, user model. We'll go into all that stuff here in just a moment. But there is another cool way, another cool thing you can do with this is I actually set up my digital inputs to my Cartesian zone so that I can use it inside of my logic. Because right now we're just sending in our SafeIO, we're sending this through the safety as a SIP safety output. Well, I can't see that in my logic. Say I want to be able to see that. I want to know when I'm in the zone inside the robot. I want to be able to see that. Well, if we go to digital IO, we go to type 3, it has to be a digital input. We go to config, go ahead and take a snapshot of this because this is some pretty cool stuff. When I come over here to this rack 36 slot 10.1, it's going to say, sorry, my 210 to 219. It's going to say DCS CPC. I set these up from digital inputs 210 to 219 as my Cartesian Position Check zones. That way I can use it in my logic. Say you want to do some kind of homing routine based off of your Cartesian zones. Well, you can do that. I also set my safety inputs from the PLC, SIP safety inputs, so I can see them as digital inputs. Say for some reason you want to see SIP safety input as a digital input in your logic. You can do that with this configuration here. 36, 10, 1, that combination will get you SIP safety inputs as digital inputs. If you want to be able to have the ability to disable and enable zones, you can set it up and you want to disable and enable Cartesian zones via a PLC. So we go back into that Cartesian zone. Here is a disabling input. You want that PLC, so we go back to our IO sheet. SIP safety input 1. We're not using it. So let's use SIP safety input 1. We're not using it for anything. I could change this to CSI 1. That way the PLC can enable and disable a Cartesian zone depending on an operator input, whether they're in proximity, whatever, or an area scanner, or an area scanner is broken, you can enable a Cartesian zone. I just wanted to show you that that is how you could use a PLC. You don't have to do any mapping in Safe IO. It's already done. Really quickly, I wanted to show you this on the setup side of things. If you go to menu, IO, and you go over here to Ethernet IP, you press enter on the teach pennant. And as long as you have that safety Ethernet IP option, I'll show you that again. As long as you have this option available, Ethernet IP safety, then F3 will populate and it's going to say safety. Here you can click on this. Before you get your safety communications going with your PLC, you have to come over here to Ethernet IP safety and you have to point it to what Ethernet port you plugged into. So let's take a look at this. When you open this at first, it's going to say undefined. Okay. We just need to point it to port 1 or port 2. Port 1 is CD38A. So if you're using that, make sure you have it pointed at port 1. Same thing in your host comms, which we've gone over this in a previous video, so I'm not gonna go on about it too much. But you can see here, port 1, port 2. That's what it's talking about. Port 1 is CD38A, port 2 is CD38B. So just make sure you get that set up and going before you start to get your PLC talking. Once you set your IO sizes, all that stuff, IO sizes are automatically defaulted to 2 and 2. 2 bytes in, 2 bytes out. It's enough for me. It should be enough for you. If for some reason 2 bytes in and out on DCS on the safety slot is not enough room, you can go to the DCS, you can go to SIP safety, and here you can configure IO sizes in bytes. I believe in the PLC it's configured in bits or words. I can't remember. Just make sure you get the right sizes because the PLC you will never be able to set the safety network number. You will never be able to get the PLC module running if you don't have your IO sizes right, which it will tell you in the connections tab on the PLC. Enough of that. Enough of PLC. Let's get back to the robot. I don't have a PLC. So I can't enable and disable a Cartesian zone or a speed check with the PLC. Instead, I'm going to use a digital output to disable and enable a zone. Well, in this list, there are no digital outputs available. They don't let you. It's not a safety input. Digital output is not an options of means of disabling a Cartesian or a speed check zone. You cannot use a digital output. However, we go back to my Safe IO. Let's go back to the beginning. Let's go back to the digital output side. So let's scroll on over here. At digital output, starting at bit 1, sorry, that's not right. Ignore the group output. I meant to delete that. Starting at digital outputs 200 to 210. In the robot, you can see it's here. I configured digital outputs 200 to 210 at this combination. Rack 36, slot 0, starting point 1. So now in my digital outputs, I have now configured 200 to 210 as NSIs. You look at this combination, you click on that rack, it's going to tell you down here at the bottom, NSIs. Still, we cannot use NSIs to disable or enable zones. So now that we have digital outputs 200 to 210 configured as NSIs, we come over here to DCS, we come over here to Safe IO details, we turn NSIs and SIRs equal to each other. So SIR1 equals NSI1, SIR2 NSI stands for non-safety input. SIR stands for safety internal relay. I don't care about all that. All I know is when I want to disable and enable a Cartesian zone, SIR is an option. So I would change this to 2. I even have a comment in here. If you want to give your SIRs and CSIs a comment, you come in here to DCS, Safe IO status. You want to have a comment like mine is, you can go into statuses, CSIs. Here's your CSIs and SIRs, which is here. This will give you that nice comment, and it even shows you their status. So it's super nice. It makes it a little bit cleaner and easier to understand when you're setting this up. So it appears that we have some DCS changes that we have to make. Actually, just kidding. So I'll show you what this looks like real quick. If we do a display 2, we come down here to digital outputs. I come down here to my NSIs. CPC 1, NSI 2. That's what we had this configured, right? SIR 2. Well, SIR 2 is equal to NSI 2, remember? So we'll go back to our position check, details, SIR 2. So when I turn this NSI 2 on, it should turn on SIR 2, which would disable this zone, as indicated at the top. So it's really neat to be able to do that, especially if you're trying to create simulations inside of RoboGuide. It's really handy to be able to do that all from the teach pennant. But just be careful. Be careful. So let's set up a Cartesian zone. So right now I have a Cartesian zone around my pick in place. Again, these are nonstop zones. Let's take a look at that. Let's take a look at this zone here, the pick zone. I really hope this video doesn't crash because I'm not stopping. I'm not stopping. So I have this set up, robot model. So when you're doing this, press next on the teach pendant and press 4D. Hopefully you have the 4D option. Hopefully that you can be able to do this. Because without it, it makes it extremely difficult if you do not have 4D to be able to look and see what you're doing. So again, anywhere on the DCS page, anywhere, if you press next, you can click 4D and it's going to take you to a 4D representation of what you have highlighted in DCS. So if I highlight the place, it's going to show the place on here. You can see it over there. If I highlight the pick, it's going to show it over here. If I go back, it's going to show both of them. So very handy. It's almost necessary to be able to have 4D graphics to be able to set up your Cartesian zones. I mean, it's almost necessary because it can be extremely difficult to do without having a 4D graphic. So the first thing you're going to want to do is enable that zone so that you can start to see it being built over in 4D graphics. Robot model puts a Cartesian or puts a DCS zone around each joint and each axis of the robot. Super handy. You don't have to do that. It does that for you. You can see that over here on my RoboGuide. That's what those bubbles are. If for some reason you just wanted the end of arm tool, or you don't want the robot model, you can come over here and say disable. You're going to see that represented immediately in your 4D graphics. Again, very handy. I'm going to come back here. I'm going to enable this. Now, this is what yours is going to look like. Yours is going to look blank. You're not going to have anything around your end of arm tool. It's just going to be blank. We have to set up a user model. So find a user model, find a blank one, whatever. I chose user model 1. There's 2 ways to get to user models. You can either highlight user model, come over here, press F1 for model. It's going to take you over to these and press detail for user model 1. Another way to get to it is just come over here to user models in the DCS menu, details. You can attach multiple user models to one model, but I'm not going to get that complicated. We're just going to do a model over the end of arm tool. I have selected box. I put the dimensions in, and it put this nice little box over my end of arm tool. That protects your tool because the robot doesn't know the dimensions and the size of the end of arm tool. You have to be able to put those dimensions in your user model to tell the robot what does that model look like. Now, I set up a box here. And make sure you enable it here. So we'll go back to that Cartesian zone. We're using user model 1. We're using that box. And then our method is restricted zone diagonal. Diagonal means you get 2 points. It's catty corner. So you define point 1 and then you define point 2 and then it makes a cube. It's really nice. It's super handy and it's faster to use. If for some reason you want to use 4 points instead, let's come over here and look at this. We can do, it would be working or restricted zone lines. That gives you the ability to use more than 2 points. I do not recommend using anything more than 4 points. If you have some kind of complex shape that's not a square or a rectangle, I would recommend making multiple zones because every time I have tried to make a zone that's more than 4 vertices, anything that's more than 4, RoboGuide tells me that it's a complex polygon and that it's not able to do it. So whatever, no big deal. I'll just make an extra zone. While you are making DCS zones, Fanuc gives you 32 of them. Very nice of them. It's plenty of room to make 32 different zones. However, you are limited not by how many zones you can make, but your processing time that they give you. Max, you have to pay attention to this as you're making your zones, especially if you're using nonstop zones that aren't necessarily essential, like restricted zones are or working zones are, and emergency stops like fences, and which are essential. When you're using nonstop zones, you really, anytime you're making zones, you have to pay attention to this number on the right. We're already at 609, and I only have 3 zones. Actually, I only have 2 zones enabled, and we're already at 609 processing time. That's with 2 zones. So you can imagine the more zones that you make, the quicker it starts to stack up. If you exceed 1,000 and you come here to apply, it will not say code number, which is 1111. It will not say code number. It will say processing time too much, processing time exceeded, some kind of ambiguous language like that. It's very confusing. You come over here. This is what it's talking about. Process time factor 1,000. One way to curb your processing time, and it's not by much, is instead of using a box around your tool, instead of using a box around your end of arm tool, you use a line segment. So let's go look at this model. Let's go to details. So instead of using a box, I use a line segment. You can use a point, 2 spheres, however you want to set it up. Just don't use a box. For some reason, a box, it just think of the amount of mathematics and geometry and all this mathematics the robot's doing in the background to calculate its path. When you use a box, it's doing all this extra math, Pythagorean theorem, all this extra math. When you use a sphere, it doesn't take as much processing time. So that's one thing to help curb your processing time. So let's see if I can do this real quick. I'll use model 1. So we can see that using 2 boxy end of arm tools shot up my processing time to 732. I go back here and I instead use my line segment, and it's not by much, but it shot it down almost 132 points, almost 132 milliseconds of time off of my processing time. So using a sphere on your end of arm tool can help you in a pinch when you just need a little bit less processing time and you have multiple zones. Change them all to line segments, change them all to a sphere, and that can help you with your processing time. So that's a little bit about setting up Cartesian zones. Again, all my zones are set up as restricted zone diagonal. That doesn't mean it's restricted. This is what makes it restricted. Restricted zone means it's a zone that when you're in it, you're not supposed to be. A working zone is gonna be a zone that you define as the box that the robot's supposed to be working in. So here we have, so say if you have a fence, you have a fence here. If you did a restricted zone, you would have to do a box over this fence, then you'd have to do another box. So you'd have to do 2 zones just to protect against this fence. 2 fences, 2 fence panels. Instead, you could do a working zone lines, working zone diagonals, and this is going to define the 2 points. So let's do that real quick. I'm going to jog the robot like you would in the real world. Shift record, come over here and jog. Try to jog the robot to the other point. Shift record. I messed that up. Let's try that again. Come over to the other point, shift record. And you can see it puts together kind of like a rough estimate of where you put those boxes. Then I recommend putting the robot in world, because then you can see the coordinates and you can see, hey, I need to go positive y in point 2. Right, my point 2 needs to go positive y. Let's say 500. Let's just punch them in, punch numbers in, and try to get it dialed in. That's what I do. I kind of punch numbers in, I fudge them in there until I get a box that's right, and then I test it and move the robot around. Remember, this is a working zone. So you see this robot sticking outside of this working zone. That would not be possible if I had this enabled. Let me show you what a restricted zone looks like. I am not going to enable that zone. I'm going to turn my pick zone into a restricted zone, category 0. What is category 0? Category 0 is no different than a knee stop. It's going to stop as fast as possible. Stop category 1 is the robot's going to stop, but it's going to come to a controlled stop rather than an emergency. So let me show you what that looks like. Stop category 0, apply DCS settings, code 1111. Yes, I know what changes I made. And then we're going to cycle power to the robot function next. 8 cycle power. What I expect to see is we're going to jog the robot into that zone, and we're going to expect the robot to stop when it gets into the zone or close to it. Stop prediction is an option that Fanuc gives you to be able to help the robot kind of predict, like, hey, I'm going this fast, and I know if I continue going this fast at this velocity and at this angle, I'm going to hit this zone at this time. DCS zones look a little goofy here. Let's see if we can clean this up here. Go to DCS. Oh, it would appear that I overwrote one of them. That's okay. We'll just disable that for now. Click OK, and we will cycle power real quick, because I don't want to. Once you make a DCS change, it's going to throw an alarm at you, letting you know that you have to apply a DCS parameter, and it's going to continue to fault out until you apply that DCS parameter. You can still jog, but as soon as you let go of shift, it's going to immediately fault out again. You got to reset it 300 times. It's inconvenient. So it's a lot easier on RoboGuide, especially when you apply. You're going to notice that applying a DCS parameter on RoboGuide is 10 times faster than it is doing it on the real world robot, especially if you have a cobot application. I have learned recently that when you try to apply DCS parameters on a cobot, you're going to be waiting for a while. So let's send this robot home. And then I am going to jog. What is that? Y positive? I'm backwards here. So see, Y positive, boom. As soon as it hits that zone, it's going to stop. Don't look at the part here. In fact, let me try to hide this because it makes it a little bit confusing. It's stopping when it hits this user model that we created. It's going to stop when it hits that box. That's why it's very important to make sure you get your DCS zones dialed in and then test, verify, make sure the robot stops. Do it 100 times if you have to before you get it dialed in, and then run at full auto speed to test your DCS zone, because it's different. You can just be barely scraping by a DCS zone, and it seems like your path is good when you're teaching in T1 mode and you're testing in T1 mode, but then you do it in auto, and it's a totally different story, right? You fly past it going 2,000 millimeters a second instead of 250, and that stop prediction, it changes the way it looks at that DCS zone. So depending on how fast you're going, if you're just barely scraping by a DCS zone, you could very well fall, even though you were never going to hit that zone. You know you were never going to hit it because you test in T1 mode. Make sure you also test at full operating speed. Whatever that speed is, 2,000 millimeters a second, make sure you test that as well before you say it's good to go. All right. I see that we're already at 30 minutes. I knew that was going to happen. Let's look at speed checks. Speed check. And we get an alarm letting us know that, hey man, we're in a restricted zone. We're not supposed to be there. So let's go ahead and look at speed check. Menu 0, system, DCS, Cartesian Speed Check. There's a lot of information here. I'm only looking at about 4 things on here. First, we enable stop type category 0. It's a failsafe. I am doing an override speed. Even though this is a Cartesian speed check, I am saying whenever my override is enabled, enact an override of 0%. If you want it to be Cartesian, you can change your choice to cart speed. Okay, you have to put in a limit of, let's say, 250 millimeters a second. And then you come in here and you say, excuse me, I want to use Cartesian speed as my limiting factor instead of override. I like using override. It's very straightforward, but depending on your application, I just wanted to show you both of them. So what this basically means is, oh, there's my DCS change. Let's get that in there. Okay, back to where we were. So when I'm looking at this, what I'm seeing is when I tell the robot tells itself to, hey, go into a speed check of an override of 0%. I am giving you 1,000 milliseconds to ramp down to 0 and 1,000 millimeters permissible stopping distance. You are going to have to play around with these numbers and figure out what is your safe distance calculation. You're going to have to go through that for yourself on your own. Because what can happen is, if you don't give the robot a long enough delay time, is when the robot's traveling at 2,000 millimeters a second and you're saying go to 0% override, go to 0 millimeters a second, it's going to take some time to get there. So the robot's saying go to 0% and it sees the robot's not at 0%, you're going to fault out for a speed check. So you're going to have to put the speed check in, make sure you get a move where the robot's traveling at its fastest speed, and enable and disable that speed check and make sure that it slows down, it ramps up, it slows down, it ramps up. So let me disable and enable my Cartesian, or my Cartesian speed check. I am using SIR1 as we remember before. SIR1 equals NSI1, NSI1 equals digital output 200. So we can do this all from the teach pennant. So I'm going to come over here to my digital outputs. Digital output, I'm going to shoot on down to digital output 200. As soon as I turn this off, we can see that the speed check is safe, it's enabled, it's happy, and my override is 0. I turn that back on, it's going to shoot me back to 100%. Sometimes, in my experience, the robot does not go back to the speed that it was previously at. So if I go into a speed check, say I'm telling the robot right now go to 0%, and then I disable speed check, I have had it stay at 0, and I've had to logically tell the robot go back and ramp back up speed to 100% or 80% or whatever you want. There's 2 ways you can go about it. You can do it in your logic, you can do it in your code, you can do override calls here, though I don't recommend it, and I'll tell you in a second. Here's why. You could also do an override select where you have the digital input ramp the speed back up. Again, this is after the speed check is disabled and it's time to ramp speed back up. If for some reason your robot isn't ramping its override back up to where it was before, you might have to do some logic or an override select with your digital inputs. Consequences that takes away the flexibility of being able to change your override dynamically as the robot's running in auto. Here's the big issue with calling override speed in your logic using an override select. Doing a speed check does not stop the robot from executing lines of code, especially if it's above 0% speed. When it's 0%, it's going to get to that position register and it is going to stop there, because if it's running 0%, right, it's never going to make it to that position, thus it never executes the next line. You have to be cautious when you're using override selects, and I will show you. I will show you why. So I am going to let this robot run this code. I think I might hit that DCS zone. Oh, nope, we're good. Okay. Here's what's going to happen. I'm going to tell the robot to go to 0%, and then it's going to execute that override. It's going to execute this line of code. And for a split second, the robot saying go to 0%, go to 0%, and then it executes override 100, and then it shoots up to 100 in a millisecond, and then the robot shoots it back down to 0 to the speed check. So for a millisecond, there is a conflicting speed. The logic saying go faster than 0%, but the speed check saying go to 0%. What's going to happen? It's going to fault out. How is it going to fault out? As a failsafe, we say if there's ever a time shall the robot exceed 0% when I'm telling you to go 0%, if there's ever a time that you go faster than 0%, then enact a stop category 0. Enact an emergency stop, because the robot's going faster than I'm telling that it should. So let's go back and run this code here. Sure, start at that line. Go to my IO. Function abort. Function abort. Let's start up here. And boom, because it executed this line, right, we get this, we get a fault. Because it just because it executed that override statement. So you have to be very careful when you're using speed checks and you're also calling out override speed in your logic. This has gotten me before, and so I'm sharing that information with you as well. Very quickly, to wrap this video up, I know that we're already almost at 40 minutes, but I wanted to show you how you can do homing based on Cartesian zones. So here's a perfect example of, if you see here, I am turning off and on my speed check. Even though I'm turning it on and I'm disabling my speed check, my speed is staying at 0%. This could be an issue that you run into when you're doing your speed check. So just be aware that you may have to use the PLC to ramp the speed back up to 100% or 85%. But again, that it sucks because it limits the ability to change the speed of the robot. So I'm just putting this out there for you guys. Another cool thing that you can do is, because we configured digital inputs 210 to 36, down here it says CPC, we go to monitor. The robot lets us know when it's in this zone. I'm going to have to do a couple things real quick. For one, I'm going to have to make that a non-stop zone. So let's go ahead and do that. Let's turn this into a non-stop. Right, we don't want the robot to stop when it's in this zone. We're going to apply those DCS settings, and we are going to cycle power. We're going to try to cycle power. What's cool is, if you already have DCS zones set up, put it in your logic. Use digital inputs, and you can use that to say, hey, I know the robot's in this Cartesian zone, and thus execute these lines to get to find yourself back home. It's a really quick and easy way to do homing, but you have to be careful because of your processing time. So if you're using nonstop zones, that's all great and all, but if your nonstop zones and your restricted zones are starting to add up beyond that 1,000 processing time, it's out the window. And you're going to have to go back to using them just for restricted zones, because nonstop zones are not important, right? They're just there to help us out. So it's really cool because now I can say, maybe. Oh, I think that's going to open up my Cartesian zone. Sorry guys, I'm trying to. There we goes. So like I said, these are clear of bits. So when the robot is out of the zone, that the output, or in this case, the digital input, is held high. When you're in the zone, the digital input is low. There's no PLC turning this on. It's all happening internal via our mapping. So now that we know that we're here, we can do some pretty cool stuff to get us back home. There you go. Obviously, it would be something a little bit more sophisticated. It's just a very simple way to show you guys that you can home. You can put Cartesian zones, whether you're in them or out of them, inside of your logic. It's a really neat way and a unique way to be able to home. Sorry about that, guys. My audio cut out. Appreciate you guys tuning in. If you find value in my content, please like and subscribe so I know that you guys are digging the content that I'm putting out there. And if so, I'll be sure to put more stuff out there that's nowhere to be found, nowhere else but here at Robotic Engineer Automation. Thank you guys. I'll catch you next time.